Hey guys, I'm coming to you from the Caribbean, down in the Bahamas in the Caribbean Sea somewhere. We were lucky enough during this pandemic to be able to fly down. And I think we saw Kelly Ripa. Well, maybe it wasn't her, but it was. Anyway, what I'm gonna do is I'm gonna measure the depth from the surface of the water here to the bottom of the sea where I'm at. And the surface of the water we're going to consider at 0 feet. Anything above the surface of the water is going to be positive. Anything that's below the surface is going to be considered negative. So I'm going to measure the negative depth of the surface right now, or the water. It's about 12 feet. So we can say that can be represented by -12. So from the surface or sea level down 12 feet is -12. I'll be with you in a minute. We got to get back on the boat. All right, guys, I'm as high up on the boat as I can get right now. And I'm holding this rock, this pebble we got from the shoreline, 16 feet above the sea, above the Caribbean Sea, and I'm going to drop it. Now, it has sunk all the way to the bottom. Once I released the pebble from 16 feet above sea level, it dropped 16 feet to reach the sea level, and then it dropped or fell an additional 12 feet to the bottom of the sea floor. So in all, the pebble fell 28 feet. For this situational integers, I've placed a thermometer in my freezer. And I'm getting ready to pull it out and check the temperature on it right now. So let's go. And here it is. You see the Fahrenheit temperature is on the right. It's not labeled negative, but the numbers below 0 there are negative. What I'm gonna do with this, I'm gonna take it outside and I'm gonna place it in the sunlight. And then we're gonna calculate the difference in the temperatures from the freezer into the sunlight. Now, I don't know if you've noticed this really cute butterfly here. I love butterflies. They're so peaceful and powdery. And if you ever get the opportunity, I've heard that there's this great monarch migration that occurs every fall down in Mexico, where they all congregate and they go down there for the warmer weather. And it's just, I heard it's pretty amazing. That it's a really fascinating experience. If you get a chance to go down there and check it out, I would like to do the same. Anyway, let me show you what I've done. Okay, here it is. I placed it outside. You see the temperature's already risen a lot. Now I'm gonna come back in a few minutes and when the temperature gets to its peak, and then we'll check it and see what it is. So be back shortly. Okay guys, I'm on my way to retrieve the thermometer, and remember I set this thing out in direct sunlight, so it didn't take long, and it's going to be really hot in direct sunlight. Let's take a look at it. Okay, here's our reading, and that's what it got up to in the direct sunlight. All right, I'm going to take this thermometer, I'm going to return to a shady region so that we can do some calculations. You know, I don't want to sun damage this beautiful skin. All right, so here we go. So what we're looking at here with the thermometer is, I want you to find the difference between the lowest temperature and the highest temperature achieved. So in other words, what's the difference between 114 degrees and -8 degrees? So what we can do is simplify this expression. We can take 114 minus -8 and simplify it, solve. We can go ET. So we can change our minus a negative, which is the same as addition, to plus. So we end up with 114 plus 8. And then that will simplify to 122. So the difference between the two temperatures that were on the thermometer, -8 and 114, is 122 degrees. We can also display this with the thermometer itself, since the thermometer is really just a vertical number line. And if we look at the temperature that we began with, -8, when I pulled the thermometer out of the freezer, if we go from -8 to 0, how many units did we move? We moved 8 units. And then if we move from 0 up to 114 degrees, which was the maximum temperature that it reached, then we moved 114 degrees. So we moved 8 degrees up to 0, then we moved an additional 114 degrees. In all, we moved 122 degrees. Now you can also think about that from the other direction. We can start at 114 degrees and move down to 0. We've moved 114 degrees. Then we can move from 0 down to -8, and we've moved 8 degrees. In total, we moved 122 degrees on the thermometer. The main goal in football is to win by scoring the most points. However, in order to achieve that, there's an objective of getting a first down. And typically, you get 3 downs for a team to get a first down so that you can then maintain possession of the ball and continue on towards scoring. There are situations and occasions when you might get 4 downs to get a first down, but for the most part, we're looking at 3 downs to get a first down. So there'll be a first down, a second down, and a third down in order for you to get that first down so you can restart that series and maintain possession of the ball. Now, let's take a look at my team and what we accomplished. So the ball is placed on the 20-yard line. We have the ball on the 20-yard line. This is our first possession, and it's first down. Zero, W20, 5, W30, WD40, hut. On our first play, I was sacked by Mean Joe. We lost 8 yards. So basically we gained -8 yards. Omaha, Boise, C3PO, hut. Ooh. On second down, I made my best throw of the game, and it went to Mean Joe's twin brother, Mean Mo, and he gained 15 yards. So that's plus 15 for our team. It's now third down. How many yards do we need to get a first down? If we don't get a first down here, we're most likely going to have to punt the ball to the other team and give them a chance to score. So how many yards do we need to get a first down? We started at the 20. We're adding -8, and then we will add 15. Now, to solve this expression, typically you can just move left to right, which is using the order of operations, and I suggest in most cases you just go ahead and use that. It doesn't really matter in this instance whether you follow that or not. You're still going to end up with the same solution, but let's just move left to right. So we're started at the 20-yard line, and we lost 8 yards. So adding a -8 is the same as subtracting. So it's like a winking ET. So we can say 20 plus -8 is the same as 20 minus 8, which is 12. Now we're going to take that 12 and we're going to add it to the 15 yards we gained on second down. So 12 plus 15 equals 27. We are now at the 27-yard line, and we have 3 yards to go in order to get a first down. At least 3 yards to go in order to get a first down. We must make it to the 30 or beyond on third down in order to maintain possession of the ball and keep going towards a score. My team is starting with the ball at the 20-yard line. We need to move in the direction of the blue arrow. Our objective is to get to at least the red line so that we can get a first down and maintain possession of the ball. This diagram shows the results after our first play. I was sacked 8 yards behind where we started. So we added -8 yards. This diagram shows the results after our first 2 plays. The first play we lost 8 yards, or plus -8. Then from that point we gained 15 yards on our second play. So we ended up at the 27-yard line. For third down, all we need to do is gain 3 yards or more to get another first down.